This video is going to cover Chapter 10, Section 3, which is applying properties of chords. So we already learned what a chord is in a circle, but now we're going to go into a little bit more depth about what you can do with the lengths of those segments. So Theorem 10.3, which again, the number's not important, but what it says is that in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So remember, the words if and only if mean that this can be written both forwards and back and still be true. So forwards it says if there's two minor arcs that are congruent, then the corresponding chords are congruent. So if I look at the diagram that's there, if the two arcs were marked as congruent, if AB was congruent to CD, then I can say that segment AB is congruent to segment CD. If I reverse the order, then it says that if the chords are congruent, so if we say the chords are congruent, so I know these two are congruent first, then I can say that the arcs are congruent. So I could say that if AB is congruent to BC, then arc AB is also congruent to arc CD. Theorem 10.4 says if one chord is a perpendicular bisector of another chord, then the first chord is a diameter. So a couple important parts here, and one is that it says one is the perpendicular bisector of the other chord. Hopefully you remember perpendicular, which means that it's a right angle, and then bisector means that it cuts it in half. So I should see something like congruency marks like these, or it will tell you that P is the midpoint of that segment, or it will give you lengths like 3 and 3, something like that, to let you know that that would be the perpendicular bisector. So if that's the case, then this segment here in this case would be SQ is the diameter. So if a chord like this is both perpendicular and bisected by that chord, then the other chord, which is that SQ, would be the diameter of the circle. And 10.5 says, if a diameter of a circle is perpendicular to a chord, then its diameter bisects the chord and its arc. So this is the converse of the last one. This time we know that there's a diameter, so we know G is the diameter, and also that it's perpendicular to this chord. If those two things are true, then I know that FH is cut into two congruent parts. And not only does it bisect that chord, but it also bisects the arc, which means FG would be congruent. Arc FG would be congruent to arc GD. Okay, last theorem. 10.6 says in the same circle or in congruent circles, so remember congruent circles would be circles with the same radii, that two chords are congruent if and only if they are equidistant from the center. So in this diagram, I've got two chords, chord A, B, and chord C, D, and these would be congruent if and only if they're equidistant from E. Now the way we show equidistant, if you remember when we did this with our angle bisectors, is that it has to have a right angle, and then these two would have to be marked as congruent. So you would see something like a statement, EF is congruent to EG. You'd see it marked like we just marked it, or you'd see a length like 3 and 3 where you would know that those two are congruent. So if the chords are equidistant from the center, they're congruent, and because this is an if and only if, I can flip that and say if chords are equidistant, or sorry, if chords are congruent, then they are equidistant from the center. So if AB is equal to CD, then EF equals EG, or they're equidistant. And if EF equals EG and that right angle is there, then AB is congruent to CD. Okay, so now let's try some application of these 4 theorems. Example 1, it says find the value of x and y. We've got A, B, C here. So I'm going to zoom in on A. And let's see what we've got going on. First of all, hopefully you can identify that there's a diameter here. So this is my diameter. It gives me the length of the radius here is 13. I've got a chord. And this diameter is perpendicular to that chord. So that tells me it divides it into 2 equal parts. X is going to be congruent to y. I don't know. I know what this segment is because it's 5. I don't know why, x or y obviously, but if this is a radius and this is a radius, this is also 13. And then I get my small right triangle here. That one side length is 5, the hypotenuse is 13, and hopefully you remember your triple is 5, 12, 13, so x is 12. And then because these two are congruent, if x is 12, y is also 12. Okay, moving on to B. So this time it says find x and y, and also we want to find arc AB. So let's look at what we've got. We've again, this time we have a radius, but we don't have a length on it here. We do have the radius here. The length is 6. But that's not what y is. Y is only from here to here. X is on the bottom. The other piece of information I have is that this angle here is 60. Because this is perpendicular and I've got that right angle, I have drawn here a 30, 60, 90 triangle. 60's at the top, 30 would be here. The side I know is 6. This is my x and this is my y. So also from the last chapter, the right triangle trig, we should remember that opposite the 30 is A, opposite the 60 is A root 3, and opposite the 90 is 2A, and that's the one we have a length on. So if 2A equals 6, A equals 3, that makes X 3 root 3, and it makes Y just 3. So now I have those lengths. This is 3 root 3, and this is 3. Now the last thing it wants is arc AB. So remember that we said if this would end up being a diameter is perpendicular to a chord, it's going to bisect it and also its arc. So because this here is a central angle, that's 60 degrees, this arc here is 60 degrees. This would be equal to that, and AB, using the arc addition postulate, would be 120 degrees. So it's a little tricky because now we're not only learning about all these new theorems, but we're also having to apply stuff we've learned from previous chapters. I keep telling you that stuff's not going away, and I meant it. All right, C. This time we have 2 chords. And we have them shown as equidistant from the center. So these are those are congruency marks. Here's my right angle marks. That tells you that that's true distance. So if 2 chords are equidistant from the center, then these 2 chords are congruent. This whole chord is equal to this whole chord. Now I only have half this chord, but I know it's half because if I extend this, this is the diameter. If it's perpendicular, then it's going to cut it into 2 congruent pieces. This would be 8, making y 8 plus 8, or 16. All right, example 2 says find the measure of arc CD in the diagram. So in this diagram, we've got a diameter hitting a chord at a right angle, which means it is bisecting that chord, cutting it into 2 equal parts, and also its arc, which means 9x equals 80 minus x. Add the x. 10x equals 80. Divide by 10. And x is 8. But it's asking for the measure of arc CD. So I have to take that 8 and plug it back in. I can plug it back in here, or I can plug it back in there. Either way, I get 9 times 8, which is 72 degrees, or 80 minus 8, which is also 72 degrees. So you only needed to do it in one or the other, but it's a good idea to do it in both because it'll check your answer. Okay, last example, which is example 3, says in the diagram of circle C, QR equals ST equals 16, find CU. So QR, which is one chord, equals ST, and they're both 16, which it's already labeled. From that alone, we know that these are equal, and if they're equal, then it means the arcs are equal if we need the arc, but it also means that it's equidistant from the center. Because it has this right angle, I know that these are showing true distance, which means 2x is going to equal 5x minus 9. So I can subtract the 5x. Negative 3x equals negative 9. Divide by negative 9. And x is 3. So that's x, and what it's asking for up here is CU. So I can take the x. I could actually plug it into either or. This time it's probably easier to plug it in to the CU, 2 times 3, which is 6. If you want to check it with this one, 5 times 3 minus 9, 15 minus 9, which is also 6. So the the length of CU would be 6. So the 16 was not part of my actual measurement here, but what the 16 on both sides told me was that they were equidistant, or they're congruent, and if they're congruent, then we know they're equidistant from the center. Okay, that wraps up the notes for today. Take a minute to submit your notes to today's assignment. So 219, classwork 3, 10.3 notes. Make sure you submit them there so you get your full credit. Make sure you submit them before you leave. And then you can use the rest of the time to work on 219, homework 3, 10.3 homework. That will be due tomorrow, 8 a.m. Have a great day, guys.